Hello, I'm Mr. Franklin. Today we're going to be looking at scientific process. So when we do an experiment, the first thing we're always going to be looking for is we're going to be asking a question. Sometimes the experiment we're going to do, the question is asked for us, but ultimately this should be something where we observe a phenomenon, something's happening, and we go, I wonder why that's happening. So in this case, we're looking at a pendulum. So we're going to ask a question. And in this case, we're going to look at how does the release angle affect the period? Of a pendulum. So that's the question we're going to be using for this example. So the next step is to design the experiment. So in our experiment, the first thing we should look at is what is our independent variable or dependent variable. So and it depends on what's going on, but a lot of times it's easy to start with the dependent variable. What are we going to be measuring as a result at the end of the experiment? We're going to be measuring the period. So our dependent variable is going to be the period. What item are we going to be putting into the system? An input, that's one way to remember it. Input that's going to affect this outcome, and we said it's going to be the release angle. So that would be my independent variable. So I've got a pendulum. I've got something that's going to swing back and forth, okay? So the angle that I release it at, or if I just pull it back here and release it, the angle, this is what we're asking about, is what is that angle that we release it at? What are some things I'm going to need to control to make this be a valid test? So some things we came up with in class was the weight at the end of the string. We talked about string length. We talked about force of a push or just letting go. Okay? We talked about those things. Now I want you to notice here, these are things we could also test as an independent variable in a future experiment. So we could do weight, but we only want to test one, because if we don't, if we get, based on our results, we may not know which one. If we do two at the same time, we won't know which one is actually affecting the experiment. So we're going to do one at a time, and then we're going to do this one together, and then we're going to let you play with and do some of these on your own. Okay? So the next thing we do in physics, and this is like units is a non-negotiable. You always put the units with numbers. You will always illustrate when we're dealing with experiments and word problems, that kind of a thing, because a pendulum, here, let's draw it. So we got our stand, okay, and we got the arm, and then we've got the string, and it's called a bob, and we're gonna pull it back and release it. Okay, so we've got our pendulum, and then it's going to swing. It's going to swing back and forth. It's actually going to swing all the way over. Okay, and then come back. But this is pretty simple, and maybe a picture isn't as necessary, but when we start dealing with more complicated systems, more complicated motion, things that are harder to understand, a picture is going to be necessary. You're not going to be able to figure it out without a picture. So, picture. We're always going to have a picture. The next step is, now that we've kind of got an idea of what our experiment is going to be about, now we're going to make a hypothesis. And this is the general statement we came up with. As the independent variable increases, now in this class, most of the time they're going to increase, but you could also say instead of increase, is this is the planned change. Okay? So, because the independent variable is an input, we plan that, we control that. So we're gonna, as the independent variable, whatever that planned change is, so we're gonna increase the angle, and you'll see that in a second. The dependent variable will result in a measured change, and we're gonna make a guess as to what that's gonna be. So let's do this. As the release angle increases, let's keep it at increases, the period will, what do you think? Will it increase? This period is a time, so we got our pendulum, it's going to swing. If I release it higher and higher, what do you think is going to happen? Is it going to take longer for it to swing? Is it going to go faster and take a shorter amount of time? What do you think is going to be? Okay? So we said in class, we said the period will increase. Okay? So now we're going to collect our data. Okay, so that's our hypothesis. So now we're going to collect our data. So we always do a data table. Start off with our independent variable goes here, our dependent variable goes here. This is often the x and the y, which is helpful for when we graph. Okay? But our independent variable was an angle. So we can write angle. And we always put units. So we're going to use degrees. In physics, we often use radians, but we're not going to get into what that conversion is and all that stuff. We're going to keep it simple. So we're going to do, let's keep it simple. We're going to do 30 degrees, 60 degrees, and 90 degrees. So it's my independent variable. I'm planning what I'm going to do. So that's my input. I'm planning that. And then we're about to do the experiment, and we're going to record our information. Okay? So I'm going to stop the video here. I'm going to get the equipment to do the experiment, and so I can measure the angle, and we're going to try this. Here we go. 1 second. Reset. 1.09. 1.13. Okay. Let's try this again. Okay. I'm getting about 1.10 on all my times here. So I'm getting about 1.10. Okay, so I did several trials, and we got 1.10, 1.13, and 1.10 here for our times. So we collected our data. The next step is we're going to graph. There's going to be another video which you can click on and see all the mechanics of going into graphing, but I'm just going to do this quickly. So we've got our angle in degrees, and we've got that's a shorthand for angle, and then it looks like a less than, but that's actually supposed to be flat with the line that you're using on your graph paper. And then our dependent variable, which I never labeled, is period in seconds. Okay, make sure you fix that, period in seconds. So this is period in seconds. And then I'm going to go 30 degrees, and it was at 1.10, 60 degrees, it was pretty much close to the same, a little bit higher, and then 90 degrees, and it was about the same. And then we would do a best fit line, and what you will see is the best fit line, which means not all the dots touch. The period is constant. So analysis. So this is what we're doing. Often results in an equation, but our analysis is the period pretty much stays the same at about 1.10 seconds. So don't forget to label your numbers. You can label them here, but you don't have to because the label is in the table. Okay? That's our period. It's constant. So our conclusion, the last step is we need to do a conclusion, and that means we need to take our analysis, what did we get, and go back to our hypothesis and go, did our hypothesis work? Did it answer the question? So first, was our hypothesis correct? No. Our hypothesis was off. The period didn't change. Did not change. So complete sentences. Okay, so I've got a claim, I state what our hypothesis was, and now I got a reason for it. Okay, so I got a claim, and then evidence. Does that answer our question? Actually, it does. It says the release angle does not affect the period of a pendulum. Okay? So those are the steps. Start with the question. Design the experiment, independent variable, dependent variable. What are some controls? Draw or describe it. And sometimes these may have to go in reverse order because we need a picture to understand what's going on. Hypothesis, as the independent variable goes through a planned change, the dependent variable will experience a measured change, and we make a guess as to what that is, and hopefully it's educated. We're going to collect data in a data table, independent variable, dependent variable, planned, measured. Okay? Then we're going to analyze it. It often results in an equation, which in this case it's a constant, and then our conclusion. We make a claim, yes or no, our hypothesis was off. It doesn't have to be exactly like that. It can basically answer this question. No, the release angle does not affect the period of a pendulum. Why? Evidence, the period was constant at 1.10 seconds in our experiment. Okay? So that is the scientific process in a nutshell. All right, thank you.